Hi everyone. Today's our first lesson in equations. Equations are a lot like expressions, where we still are going to use variables, but we're going to do something a little different with them. So get out your notes and write down today's I can sentence. I can use mental math to solve equations. And at any time during the video, if you need to catch up, just hit pause and catch up, and when you're caught up, hit play again, and we'll keep going. All right, now I want to review with you the different ways that we are going to now be seeing division and multiplication. Remember, there's traditional ways, and now there's ways that we're in algebra that we're going to start seeing these things. All right, so with division, all right, you're used to seeing things like 10 divided by 2, or you're used to seeing 10 divided by 2. All right, and now we're going to start seeing division written with the fraction bar, 10 divided by 2. And it's still the same thing. 10 divided by 2 is 5. 10 divided by 2 is 5, and 10 divided by 2 is 5. Okay? So we're going to start seeing this fraction bar used a lot more as a division symbol. So start thinking of this as the top number divided by the bottom number. All right? Now with multiplication, you are used to seeing 3 times 5, or 3 times 5. But like I said, you're going to start seeing like this, 3 times 5, or maybe even 3 times 5. Okay? Remember, if one of these is a variable, you're going to start seeing, 3 times x, or maybe even 3 times x. Okay? So if we're looking at our answers here, 3 times 5 is 15, and it's still 15 every time. 3 times 5 is 15, and 3 times 5 is 15. And actually, some of these times, you might even see, 3 times 5 and drop down with the answer, 15. Depends on if there's an equal sign or not. Okay? All right. So those symbols for multiplication and division you're going to start seeing more of now. So let's start getting used to those. All right? And remember, probably most importantly, if I have something like this, x, y, this means whatever x is times whatever y is, right? So if someone walks in and says, hey guys, x is 2 and y is, let's say 8, okay? X is 2, y is 8. This is not 28. It's 2 times 8, which we know is 16. Okay, so make sure we don't mess that part up. We keep that in mind. Okay, so today we're talking about equations and mental math. And in equations, all right, with equations, probably the most important thing is you're going to have a big old equal sign. Every time you're going to have a big old equal sign, right? Because you're going to be solving for the variable. We're going to be figuring out what letter is actually supposed to be where the variable is. All right. So today we're just focusing on equations we can solve with mental math, right? And I'm going to start us out easy. So let's look at example number 1. Example number 1. All right, let's start us out with n plus 3 equals 9. So in your head, you should be thinking, what number, when I add it to 3, gives me 9? What number plus 3 equals 9? And if you're sitting here to yourself going, all right, Mrs. Swisher, I knew the answer 5 seconds ago. All right, the answer is 6. 6 plus 3 equals 9. Now here's the kicker. When we solve an equation, our answer has to look a certain way. All right, so I'm going to get rid of this here. We can't just say 6. When we solve an equation, we have to say the letter equals 6. N equals 6. And this is your whole answer. because 6 isn't the answer to the problem. 9 is the answer to the problem. Isn't that confusing? We were trying to find the answer for the letter. We were trying to figure out what number goes where the variable is. All right, let's look at another one. Example number 2. Let's do x minus 5 equals 11. All right, so mental math now. What number, when you take away 5, gives me 11? Are you thinking? Are you thinking about that? What number minus 5 gives me 11? What number, when I take away 5, gives me 11? And the answer is 16. 16 minus 5 gives me 11. So I need to write x equals 16. That is my whole answer. X equals 16, because we just found where the x's should be the number 16. All right. These are equations, guys. You're doing equations. They're not too bad. All right, example number 3. Let's do a multiplying one. 7y equals 56. Now remember, 7y means 7 times y. All right, so mental math, 7 times what number equals 56? 7 times what number? 7 times 8 equals 56. So my answer is y equals 8, because that's the number I should put where the y is, an 8. 7 times 8 equals 56. Okay, example number 4. All right, let's look at a division example. Ooh, what number, let's see here. What number, when I divide it by 8, equals 4? Now really think about this one, right? Because everyone's initial answer is 2. Well, that's not right. Think about it. What number, when I divide it by 8, equals 4? What number divided by 8 equals 4? So what number, when I split it into 8 parts, is 4 the answer? Are you saying 32 is the answer? What's 32 divided by 8? Oh, it's 4. So where the t is should be the number 32. So t equals 32. Now those ones are a little bit harder because you got to think backwards, kind of. You got to really know your multiplication division facts. 32 divided by 8 equals 4. So where the t is should be the number 32. So t equals 32. Let's step it up a little bit. I'm going to challenge you here. Let's get into some fractions. Did everyone's guts just drop out because I said fractions? All right, 2/7 plus x equals 1 whole. Mental math. You're like, what, Mrs. Swisher? This is not mental math. It is mental math. Think about it. We want 1 whole, all right? And in this case, we're working in sevenths. So 1 whole would be 7/7. So if I already have 2/7, what would I have to add to get 7/7? We know our bottom number stays the same. Okay, we know that already because it's an adding and the bottom is a 7. So 7/7 is what we want. We already have 2/7, so we need 5/7. So x equals 5/7. Because if I have 2/7 already, if I add 5/7, now I have my 1 whole 7/7. So x equals 5/7. That's what we needed to make the whole. All right, you freaking out yet? All right, let's look here. Okay, let's do another one. All right, example number 6. You can do these. Here, let's prove it. Let's see. Y plus 2/3 equals 1 whole. Okay, so if you're thinking about this, here's what you should be thinking. What number plus 2/3 equals 1 whole? And if we're talking about thirds, 1 whole is going to be 3/3. Gives us all of it, right? So if I already have 2/3, how many thirds do I still need? Well, I still need 1/3. So y equals 1/3. Not too bad. Okay, let's try one more. I'm going to really push you this time. It's okay. It won't hurt. I promise. Okay, example number 7. X minus, minus, x minus 7/10 equals 3/10. Whoa, are you freaking out right now? This is mental math, I promise you. So what number, when I take away 7/10, leaves me with 3/10? Now we know we're working in tenths, correct? Because everything else is in tenths. So if I take away 7/10, I have left 3/10. Wow. So if I have something and I take away 7, let's just look at the top. If I have something and I take away 7, so what minus 7 equals 3? Oh, 10. 10 minus 7 equals 3, right? Okay, so 10/10 minus 7/10 equals 3/10. So x equals 10/10. Or 10/10, what could I say that is? 10 over 10, 10 out of 10 is 1 whole. So I could say x equals 1 whole. All right, now that one was a bit of a challenge one, but that's okay. Okay, you are ready. You're ready to start your quick check quiz for this chapter. Remember, it's mental math, and try to use these strategies that I've been showing you in the orange writing to think your way through these. Okay, and try to use mental math wherever you can. All right, good luck.